Okay, so now we're going to go through the concept worksheet. First question is, what is an electromagnetic wave? An electromagnetic wave is a self-propagating transverse wave that propagates not only on the electrical but the magnetic field lines. Okay, self-propagating transverse wave that oscillates through an electric and magnetic field, as you can see on the PowerPoint. Next question. Can they travel through materials? Light can travel through materials, but it can also do other cool stuff, like be reflected or be absorbed. Sometimes, like with a lens, it can be reflected, absorbed, and transmitted all at the same time. Can it travel without a medium? Absolutely. It does so every day, all day, through space, from sunlight to the earth. How do we see color? The short answer, we see color that is reflected. Black light, or black substances absorb all light, reflect none, so we see no light. White is the opposite. It reflects all light, and so we see white color. Blue, it reflects blue. Green, it reflects green. Red, it reflects red. Primary colors of light, red, green, and blue. Primary colors of pigment, cyan, magenta, and yellow. Your TV is made up of light, so it is green, red, and blue primary colors. Light travels fastest through a vacuum. There's no medium in a vacuum. There's nothing to get in the light's way, so it travels the fastest. Denser mediums slow down light. The less dense your medium is, the faster your light is going to travel. Next question, what's it called when light goes from one medium to another? Refraction. This is a really good example of refraction. His body truly is underneath his head, but they look separated because light was been slowed down by the water and it travels faster in air. Again, going back to that, denser mediums slow down light more. The law of reflection, angle of incidence is equal to angle of reflection. What did Thomas Young's experiment show us? It showed us that light acts as a wave. Here's an example of the Thomas Young experiment, and this video is all about the Thomas Young experiment as well. So check out Veritasium double slit video and you can better understand that. Is wave a particle or is light a wave or a particle? We call that the particle wave duality. It's both, because it acts like a wave and a particle. It's neither, because it's something completely different. It acts like a wave and a particle, so it could fit in a whole new category, just call it light. And it really depends on which experiment you're looking at, because at some experiments it looks like a wave, and some experiments it looks like a particle. So that's why we call it a duality. Can it travel, or what particle properties does it have? It travels through a vacuum. That's the easiest way to remember that it has particle properties, is that it travels through a vacuum. How does a rainbow work? White light is refracted through raindrops and we get the visible spectrum of light. Why is the sky blue? Nitrogen is the leading gas in our atmosphere. It scatters blue light, so the blue light is scattered throughout our atmosphere and it appears blue. Why are sunsets red? Well, the light has to travel much further than the blue light, so by the time the white light that's coming from the sun gets to your eyes, the blue, the green, the indigo, the violet has all been scattered out, and most of what's left is in the yellow, orange, and red wavelengths. Here's a summary of why the sky is blue, why sunsets are red, a little bit about visible light in our atmosphere. You can see here nitrogen, 78%. Wasn't lying. That is the most abundant gas in our atmosphere. Also talks about why the horizon is white. Next question was the other parts of the spectrum other than visible light. So visible light is located right here in the center. All the other light is here and here. There's 6 other portions of the electromagnetic spectrum other than visible light. When we say them in order of increasing frequency, it goes radio waves, microwaves, infrared, ultraviolet, X-rays, and gamma rays. in increasing wavelength, it's the opposite. Gamma rays, X-rays, ultraviolet, infrared, microwaves, and radio waves. So study this diagram, know this diagram, and you will be good to go. Some of the uses for different types of waves. Radio waves obviously are used for radios. They're also used in ultrasounds. Microwaves are used in mobile phones, in your wireless receivers, and of course in microwaves. Infrared waves are for bioimaging, fiber optic cable, remote controls, and night vision. Ultraviolet light is for whitening your teeth, getting a suntan. Also used in forensics for examining bodily fluids. X-rays obviously are used in X-rays, baggage scanners, also crystallography, all you rock collectors. Gamma rays, we view the cosmos through gamma rays, and we also use them in some of our medical technology of scanning the brain and whatnot. Also curing cancer. Next one, what's the difference between a real and virtual image? A virtual image is always going to be upright and it cannot be projected onto a surface. A real image is always going to be upside down and it can be projected onto a surface. Real images are all going to be with convergent mirrors or lenses, and divergent mirrors or lenses will be virtual images. Next question was, which mirror shows a virtual image? That would be the convex. I don't know why it says real too right here. That's dumb. No, convex mirrors. Convex mirrors show virtual images. As you can see, I'm upright in the photograph and I could not project that out into the world. A concave lens looks like this. It's a real image. You'll see here I'm upside down, and that's why it you know that it's a real image. Convex lenses show real images. You can see right here, as I was saying before, converging all at one point. The convergence of that lets you know that that's going to be a real image, and it could be projected through this lens. What does convergent mean? It means all coming together. So this is an example of sun rays coming through a lens and converging. What does diverging mean? It means coming apart from a central point. So all of these are going away. We also see this with our concave lenses and our convex mirrors. Why do we use ray diagrams? We use them to locate the image. We talked about in class how knowing where the image is going to be when you're looking through a lens will help you fix someone's vision. What is it called when light goes through, passes through an opening or around a boundary? That's diffraction. Labeling the following: this is a convex lens, this is a concave lens. A convex lens has a real focal point and therefore a real image. It is convergent. You can see all the light rays converging at this one real focal point. Concave lenses have a virtual focal point. They are divergent and therefore have a virtual image. Looking at mirrors now, this is a convex mirror. It has a virtual focal point. The rays of light are diverging from this virtual focal point and it would have a virtual image. Concave mirrors, conversely, all converge to one real focal point in front of the mirror and we see a real image. Mirrors work on what light phenomenon? Reflection. Okay, this is how mirrors work. Law of reflection, angle of incidence equals angle of reflection. How do lenses work? The phenomenon there is refraction. The phenomenon pictured here, where we see an actual object is located here, but we see the object here, that is called refraction. White light is made up of all frequencies of light, as we can see in this image. The absence of light is what we call black. Get an example, black hole uses less energy. Save that energy, save the world. How do we see color? We see colors because the frequency of light is being reflected. This apple is red because white light hits it and red light is reflected. All other wavelengths and frequencies of light are absorbed, and therefore we see the apple as red. Quiz tomorrow. Be ready.